Hey everyone, and welcome. Today we are diving into some of electricity's coolest hidden powers. We're talking about the invisible force that can actually lift metal and the crazy amount of heat it can create. You ready? Let's jump in.
Okay, so picture this. You're at a school science fair, and you see these two students, Mohini and Arkarsh, totally stumped by a model crane. Now this crane has no hook, nothing, just an iron nail with some wire wrapped around it. But then someone flips a switch and boom, it lifts a whole pile of paper clips, just like magic. So how on earth is it doing that?
Well, to solve that little science fair mystery, we first have to wrap our heads around a really fundamental connection, an invisible force that ties electricity and magnetism together.
Let's look at a super simple experiment to see this in action. We've got a battery, a switch, and a wire, and we've stretched that wire right over a regular old magnetic compass. Right now, the switch is open, so no electricity is flowing, and the compass needle, it's just doing its job, pointing north, as usual.
But here's the cool part. Watch what happens the second we close that switch. The current starts to flow and, whoa, the compass needle actually moves. It deflects. This is our big aha moment. That electric current is creating an invisible magnetic field around the wire, and it's powerful enough to physically push the needle of the compass. And this incredible discovery has a name: the magnetic effect of electric current. The concept itself is pretty simple, but it's absolutely revolutionary. Whenever electricity flows through a conductor, and that's really just a fancy word for a material that lets electricity pass through it, like a copper wire, it generates a magnetic field. You turn the current off, and poof, the field is gone. And you know, the guy who discovered this, Hans Christian Ørsted, found it completely by accident. It was 1820, he was doing a demonstration for his university students, and he just happened to notice that a compass needle on his desk twitched every single time he turned his electrical circuit on and off. He just stumbled upon this deep, profound link between two forces that, until that moment, everyone thought were totally separate.
So that's a great story, but how do we get from Ørsted's accidental discovery to that crane at the science fair? How do we put this principle into practice? Well, let's build on that idea. This brings us to something called an electromagnet. See, by taking that wire and wrapping it into a tight coil, we can actually concentrate that magnetic field and make it a lot stronger. And then, if we wrap that coil around an iron core, something as simple as an iron nail, the effect becomes way more powerful.
And there it is. That is the solution to our science fair mystery. All Mohini and Arkarsh were seeing was an iron nail, some insulated wire, and a battery. When that current flows from the battery, the nail becomes a magnet and snatches up those paper clips. The moment you stop the current, it goes right back to being a plain old nail. It's a magnet that you can turn on and off. How cool is that?
So what if you wanted to lift, say, even more paper clips? Well, you've got two main levers to pull. First, you could increase the electric current, maybe by adding another battery. Or second, you could just increase the number of times you wrap that wire around the nail. Either one of those will create a much stronger magnetic field.
But you know, while you're building this little electromagnet, you might notice something else. After it's been on for a few seconds, the wires that are connected to the battery, they start to feel a little warm. Why would that happen? Well, this actually points to electricity's other hidden power.
Yep, that little bit of warmth you feel in the wires, that's our clue to electricity's other major effect, one that you almost certainly use every single day, probably without even thinking about it.
It's called the heating effect of electric current. Honestly, the easiest way to think about it is like friction. As all that electricity is flowing through a wire, it's bumping into this kind of opposition called resistance. And all that friction converts some of that electrical energy directly into heat.
And this effect, it's the secret behind tons of your household appliances. I mean, think about it. Your electric iron, a space heater, the kettle you use to boil water, a hairdryer, even the glowing filament in an old-school light bulb. They all work by using materials that have really high resistance, specifically to generate a whole lot of heat from electricity.
Okay, so we've got these two really amazing effects, magnetism and heat. But let's back up a step. Where does that initial push, the electric current itself, even come from in our experiments? Well, it all starts with the battery.
When you get right down to it, a battery is basically a tiny, self-contained chemical power plant. It uses a chemical reaction between two different kinds of metal, we call those electrodes, and some kind of substance that sits between them called an electrolyte. It's this specific chemical process that gets the electricity flowing in the first place.
Now you know that not all batteries are the same. You've got your single-use cells like a standard AA battery. They work great until their internal chemicals are all used up, and then they're done. You have to toss them. But rechargeable batteries, like the one in your phone or laptop, are designed so that the chemical reaction can actually be reversed. That allows you to charge them up and use them over and over and over again.
So there you have it. We've unlocked two of electricity's big secrets: how it creates magnetic fields and how it generates heat. But that leaves us with one huge question. If a flow of electricity can create a magnet, do you think a magnet can be used to create electricity? Now that is a story for another time.